talk about what we're actually going to do for the rest of the year. I'm really lazy, so I don't memorize the URL. I just search for it. Okay. This is a big document called the edition guide, and I'm not going to like literally read all of this to you, but I want to sort of talk a little bit about editions. So one of the big things with Rust is that we said that once we released 1.0 in 2015, we were not going to break anyone's code. We were going to remain backwards compatible for a long time. We didn't say how long a long time was. It's really important because if we change the language and it breaks your code, like you can't write a big program if every single week the language changes, right? Because you don't have to keep up with all that stuff and everything. And so in the last couple of years, we have basically never broken anyone's code. Sometimes in small edge cases we have a little bit, but like for the most part, your code never breaks and people upgrade to the new versions of the language and everything just works. Almost all the time. We do a lot of work to make sure that this is a thing that actually happens. Like we download every open source project that exists and test the new compiler against all of them. It takes like 2 days to make sure that we don't break people's codes. We care about it a lot. But sometimes you need to do things like adding a new keyword. And the problem is that if you add a new keyword to the language, anyone who used that as a variable, their code breaks. So it's impossible. And so we came up with a system we're calling editions that basically lets you say, I'm going to like opt into some new technically breaking changes that are sort of very small differences, like on the order of adding a new keyword. And it's not just that, but it's also new versions of Rust come out every 6 weeks. And so it's really hard to pay attention to what's going on in Rust world, because if you miss 2 or 3 releases, then you may not know what's going on. And if you like, if you come back a couple months later, like all this stuff has changed, but it's all split out into these separate blog posts every 6 weeks of what's new in the language. So if you want to catch up, you have to read all the new individual things. So for these 2 reasons, we came up with this concept of editions. And so every roughly like 3 years, we're kind of going to be printing out a new like edition of Rust. And so we're using the year system. So the first one, the clicker. The first one is like Rust 2015, because that's when 1.0 came out. And then sometime at the end of this year is going to be Rust 2018. So this is going to be the first sort of real one we've released. And so there's a lot of sort of chatter in Rust world about like the edition. We haven't really talked a whole lot about it to people that are not involved in making Rust. So that's kind of why I wanted to like bring up this idea and tell you all about what's like happening in this new thing. Because there's a bunch of new features that are kind of like happening that are really cool. And some of them have actually already landed and you can use them today. And some of them are happening in the next like 2 or 3 months, sort of before the end of the year. Because when you name something 2018, you got to release it before the end of 2018. So we already had to push back one of the features a little bit. I'll talk about that in a second. But so this is sort of some of the previews of the new stuff that's been happening and some of the stuff that's coming up. So I want to sort of show you what that is. One really cool thing, and this is actually changing as of tomorrow, but it didn't happen today, so I was like, oh no, I can't update the instructions. Today you have to install it, but as of tomorrow, Cargo is going to come with a fix command. And so when you want to upgrade your code to use these new features, you can actually run this tool and you say cargo fix, and it will rewrite your code to use the new features automatically, which is really cool. And so that helps with this, like, if you had a variable, we'll talk about AsyncAwait later, but one of the new keywords is async. So if you had a variable that's name was async, I don't actually know what it changes it to. I think it might be like async1 or something, but it will like automatically change it for you so in all the places you used it, so you don't have to go through and update this stuff by hand. And so this is really important as we get bigger and bigger code bases. Like the compiler itself is about 1 million lines of code, and the part of Rust that's in Firefox is like 600,000 lines of code. And there's some companies we know about that have almost 1 million line of code bases. So when you have a small program, it's no big deal to rename a variable. But whenever you have big code bases, like you don't have to read through 1 million lines of code and update everything if you had it. So tomorrow it's going to start coming installed by default, but it lets you lets you do that. So that's one cool aspect of this new stuff. And you can kind of tell it like, do the minimum amount of work to upgrade my code so that it works, and you can say do the maximum amount of work and like change the style of my code and do all that stuff to like use fancy new features and things. So there's sort of levels you can pick. But anyway, let's talk about a couple of these features. So this is actually one that you can use today, and it is called dyn trait. And so Rust has this concept of trait objects. We didn't talk about traits in the intro, but they're sort of like interfaces. So you can say like, this variable is anything that implements this particular interface. And so the problem was we had this syntax that was like box trait like this. And the problem is that that doesn't really clearly say that this is like anything that can be part of that trait. So we added this new dyn keyword. And so now it's box dyn trait to show that it's dynamic instead. And if you're just seeing this for the first time, this feels like a really minor change. But a lot of people got really confused by this older syntax, and they find that this new one with this little extra thing, it's kind of different enough from the other ways you use traits to really like show off the fact that it's a dynamic aspect. So this just happened in like the newest version of Rust that came out 3 or 4 weeks ago. So it's sort of part of these new features, but you can use it today. And it just makes stuff a little bit clearer, especially when you're learning things. I didn't talk enough about the way that the trait syntax works in the rest of the language to show you like why it's different than other things. But this is kind of what I mean by, like, this is different than like a Rust 2.0. Like this is, oh, you add 3 letters onto the end of this, right? Like it's not like a super big change, but it is kind of like helpful for learning and understanding code. And one of the reasons why is that it's similar to this other feature, which also you can use today, called Infiltrate. And this says, a different sort of form of return any sort of possible value. And so sort of the difference is that Infiltrate is used to hide what you're returning to other people, and dynamic trait is if you have like multiple ones. So if you have a single one, use Infiltrate, and if you have multiples, use dyn trait. And that's why we sort of have 2 keywords to show the difference between one and many things. And so it was weird when there was no keyword for many, but there was a keyword for one. And so it's a little more symmetrical than sort of the two versions. Another thing is the module system. So there used to be, when you wanted to use like an external package, like when you wanted to say depend on a library in previous Rusts, you would have to add the name of the package to your cargo.toml, and you would also have to add a line in your source code that said extern crate and the name of the crate. And the reason that's there is basically history that goes back from before we had a package manager. And then we got used to it, so we sort of never removed it. But a lot of people were like, I already added it to my configuration file. Why do I need to add this line to my source code anyway? And so we made the change so that you just don't need to include it anymore, which is like a nice little kind of like thing. Many other languages don't make you say in the source code that you're using this particular thing, and so that like cleans stuff up a little bit. But some of the bigger changes, people found that the module system was very confusing. I need to scroll down past this part. So if you wanted to make a submodule, like if you say mod foo in your source code, then it would live in a source file named foo.rs or foo/mod.rs. And you couldn't have a foo.rs where the submodules all lived in a folder named foo with their names. If you had a folder, you had to use this second foo.mod.rs version. And that's kind of like a little weird. Like, why do I need 2 different forms? One if it has its own children, and one if it doesn't. And secondly, people would open like 10 files in their editors, and they're all named mod.rs because they're in folders. So then you couldn't tell like which one, you know, when you look at the tabs, you're like, I have 10 things, and I'll say mod.rs. And so that was stupid, and so we're fixing it. And so now you just say foo.rs for the foo module, and you say foo/whatever for the sub-children modules, and it just like works the way that it should have always worked. Like, it was just kind of dumb in the past, and so we're fixing it. You'd be surprised at the number of people that thought this was awesome, though. It took a lot of arguing to convince some people that like this was bad, but I saw like half the crowd nod when I was like, you open 10 files and they have the same name, so like obviously you all have felt that pain in the past. So, yeah. Yeah, exactly. You search for it, it doesn't work. Like, it's just basically worse. But yeah, so that's going to change, and that's honestly, it's one of the things I'm most excited about. It's like a really tiny change, but it just makes so much more sense. Yeah. Okay. I'm going to talk about AsyncAwait a little bit because this page is actually out of date. I need to actually remove this page, but it's fine. So AsyncAwait is a technique for doing asynchronous programming that you may have seen in other languages. And it is not going to be available at the launch of Rust 2018, but it's going to come out in like December or January, like right at the end of the year, maybe in the beginning of next year. And it has been implemented in the compiler, but only in nightly, and as of like a week ago. Like, it's like brand new that this has happened, so I need to fix this page. But let me, if you haven't used AsyncAwait before, this is going to be pretty okay. This one's fine. Let me show you this link to kind of give you the idea of what's going on. No. This one. All right, so this is sort of I like this code sample, and I didn't put it in this page, and I forgot to change it before. I just gave a talk at this conference like 3 hours ago on a totally different topic, and so I should have tweaked this last bit, but I forgot. So basically what happens is this is actually the second one. So what ends up happening is you can say that a function is asynchronous by writing this async function. And what that means is this function is going to return something that doesn't execute right away, and that value, call await on it in order to make it actually happen. And so what this lets you do is you can kind of build up a number of different things that you want to happen asynchronously, and then finally say, please execute all those things in an asynchronous way. This code sample is actually pretty bad. Should have made a better one. Sorry. But if you've used it in other languages, it looks pretty similar, and it's a really big help when writing asynchronous code, because if you don't use this sort of feature, you have to manually write out by hand like which bits are async and which bits aren't, and then thread them together through this thing, and it's like very long and complicated. And AsyncAwait lets you write code that feels like it operates in a synchronous fashion, but it actually operates in an asynchronous fashion.
Will the features be integrated?
Yes. So as part of this implementation, like the underlying concept is called futures. And so futures in Nightly are actually in the standard library now. And the compiler, basically async is, await is like syntax sugar for futures. So it writes your futures for you. That was what I meant when I was saying that it's like complicated and you have to write things. Like, yeah, it's exactly that. And so an async function returns a future, basically. And so this is going to be really cool, but again, it's taking a little longer than we expected, so I don't have a ton of great examples for you, and it's going to be a thing that happens closer to the end of the year. So I wanted to point that out, because a lot of people originally thought that it was going to be a thing that happened, and then it's not actually a thing that happened just yet. Okay, and I want to talk about two other things. So we talked about patterns briefly, which is kind of neat. But one of the weird things was that you couldn't use patterns with arrays and vectors, because the problem is that like with something like an enum, you know, okay, there's 3 parts of the enum, so I need to know that there's those 3 patterns. But an array or a vector can have like 1 thing or 2 things or 3 things. So how do you write a one pattern that's able to handle all these things? And so coming soon, but not quite ready yet, is this idea, we call them slice patterns. So for example here, this is a function called greet, and it takes in a slice of strings. I didn't really talk about slices in the intro, but slices are kind of like how you refer to an array or to a vector. And so here you can sort of write these patterns like this. So if it's an empty slice, then do this. If there's 1 thing, then do that. You know, if there's 2 things, do this. And then you can kind of say, like, if there's any other number of things. So this is going to give you the ability to, like, pick apart arrays and vectors in the same way that you do structs and enums. So it was always really weird that like some of the language was supported by match, and not the rest of it. So kind of just like finally actually sort of filling that out. And then if you have an array, since you know exactly how many things are in it, you can actually do like specifically the list of the number of things. I saw somebody was trying this feature out, and for some reason they had arrays that had 128 things in the array. And so they wanted to try this feature out, and they actually wrote out a thing with like 120 underscores, and then 5 of them that had like the right thing in it. And they were like, I don't know if I like this feature or not. And we were like, whoa, like I don't blame you if you have to write out like literally 100 things. So maybe for bigger arrays it'll be a little annoying, but like it's kind of just a nice little tiny thing. Okay, and then one last, well, I guess 2 little brief interesting things, and then we'll get to Ashley. About a year ago, we came up with this question mark operator. So what happens is if you use the question mark on something that returns an error, it's sort of like throwing an exception. And instead of you needing to handle the error right away, it returns the error from the function. So you can write all your code just like with the happy stuff, and then just like deal with the error in the function that's calling you. But the problem is that in order to do that, the function has to say that it returns something that may have an error, which is a result type, we call it. And so the problem before was that main doesn't return anything. So you couldn't use this really nice syntax in the main function of your project. You would have to like, instead, a lot of people had a 1-line main that would just call a different function named like main2 that returned the error thing just so they could use question mark inside of main. And so one of the things we're letting you do now is you can use question mark inside of main, and what happens then is your program just ends and prints out an error message and says that it didn't work. And so that's kind of the way that it should have always happened, but it didn't totally work. And the same thing with unit tests. Unit tests had to panic to fail before, and now you can write unit tests that return a normal error if you prefer to do it that way. Yeah.
You mentioned tests. What about mocks?
So mocks are complicated, and they're not very good ones yet. And maybe next year we'll be able to figure it out. But so the problem with using mocks in Rust is like Rust really cares about the types of everything, and a mock is like, please ignore the fact that this is not the thing that I actually am supposed to give you, right? So it's like kind of fundamentally at odds with strong types. But obviously there are languages where it works, and so the sort of better versions of macros that are being worked on right now, they may let us do mocks in a good way, but people don't have a good idea of the design yet. But it's definitely something people want a lot. We just need to figure out how to do it. Okay, and so AsyncAwait, like I said, mentioned before about the async keyword. So there's this weird question where like, what happens, so one aspect of this system is that if I use a library that uses old Rust, but my code uses the new Rust, that's totally legal. So you don't have to update everything to the newest version to make it work. Like I can use an old library with my new code and everything will happen just fine. But the problem is, what happens if my old code defines a function named async, but now I'm using the new version and async is a keyword? Does that mean I can't call that function? Because like now it's a keyword, so that doesn't work anymore. And so there's a small syntax called raw identifiers that lets you write a little R hash right here to sort of say like, I know that this is a keyword, but there's actually a function here called that. And that lets you do the interoperability between the sort of two universes. So that was one aspect of the addition stuff that I didn't talk a whole lot about before, but yeah, it's nice because you don't need everyone to update to the new version to use the new stuff. And like, if you want to write the old code and ignore the new stuff, people come out with the new library, you can also use the new library without updating. So that's kind of a brief overview. Obviously, there's a whole lot of stuff in this document, and we're still working on it. So that's kind of a little preview of some of the new stuff that's happening. Yeah, so now I guess thanks for listening to me talk for a little bit, and Ashley's going to show you some other stuff. Oh, maybe there's questions. I don't know. Yeah, I don't know. Just zooms, actually. I don't know.
I think it's perfect.
Yeah.
No, it's good. If any of you have any questions to say,
Yeah. well, he raised his hand first. Let's do him and then we'll do you. Yeah.
So at the beginning you were talking about cargo, and then you, for documentation, you had a Rust up. So
Yeah.
I was a bit confused about the roles between cargo and Rust up.
So RustUp is a tool that manages both the Rust compiler, Rust C, and cargo. And so it's how you update and switch between different versions. And so cargo is how you interact with your own project normally, but like RustUp manages the versions of cargo. I don't know what programming stuff, like what language do you normally write stuff in? Okay, so in this case, RustUp is sort of like, well, the problem is Maven and those tools let you say the dependencies of the language in itself, so there's not actually a direct, Ruby, Python, and JavaScript have direct analogies, but Scala doesn't, so I just missed it. But yeah, basically, yeah. Okay, so like RustUp is kind of like virtual env, and cargo is kind of like pip. So like the virtual env lets you say what version of everything you depend on, and then pip says what version of the package is. It's kind of the same sort of thing. Yeah, that's a great question. You're right. I kind of glossed over that a little bit. Yeah.
So opting into a new edition is all or nothing. You have to like
on a per package
stuff.
basis. Yes.
Oh.
So if you wanted to make it smaller, you would split the code out into those different packages.
But then, so Rust, something compiled against Rust 115 edition should link to Rust 115.
Yeah, because it's the same compiler. Like one compiler knows how to do both editions at the same time. So you don't need to have different versions of Rust installed to have the different versions of the language. You just have one thing, and it knows how to do both and link them both together.
Okay. And is there sort of an idea of how long the compilers are supposed to support the old editions?
So luckily, we only have one compiler right now, and so the plan is to support it forever. If somebody else makes a new one, they can kind of do what they want, I guess, and we'll see what happens. But part of it is you can only make tiny changes, partially so that it's easy to support all versions. So sort of on a technical level, the syntax can change, but the internals of the compiler are identical for both, which is why they interoperate. But it also means it's easy to support all of them. So we have no plans on ever dropping the original stuff.
You will keep with the 6 weeks
yes.
of the compilers, but you will have to different edition.
Yeah, well, it'll be the same. So like Rust 1.35, we'll say, just to pick a random number in the future, will support both editions. So you'd still have the same release every 6 weeks. And we're talking about maybe doing a long-term support thing as well, but we want to finish this work before we start other plans on how we do releases and things. Okay, focus on this stuff. What? I thought I talked about it at the start. Okay. I talked a lot over here, so yeah.
Is there a plan to include like an HTTP functionality in Rust?
Yeah, so this is complicated. So Rust standard library is very small, and the reason why is that we had cargo from the beginning, and there's sort of this attitude that because Rust has to be stable forever, if you put something in the standard library, it can basically never change ever again. And so the problem is when you say like there's currently no HTTP package in the standard library, and so a lot of people are like, how is that possible? And then other people are like, look, Python has URLlib and URLlib2 and then requests that everyone uses in the ecosystem. And so there's sort of this like battle going on between the people that want to put it in the standard library, and Ashley is definitely on that team, and I used to be very anti that team, but I'm maybe okay with it now. I'm not totally sure.
I'm incredibly convincing.
And then there's other people who are very against it, but what I will say for sure is the problem is that the HTTP libraries are still under really heavy development, and so it's definitely not going to happen anytime soon because we want to get the actual APIs to be really good first. Like all this AsyncAwait and futures shenanigans is like still being actively developed. And so once that's stable, it's very possible that we'll put it in, but it definitely won't happen until that's stable, which would be like early next year at the absolute earliest.
Well, past 3 of like what the API should actually look like, I feel like.
Yeah, this is like version 3, so we're feeling good about version 3, but at the same time, it is version 3. So like, you know.
The ergonomics around how, so in Rust, for those of you who don't know, the thing that you would use to write like asynchronous networking code would be called Tokyo, and below it, it has something called Mio, which is like really low level IO, and then there's the features library, and so when you stick those together, you get async code. And there has been a fair amount of drama around exactly what the ergonomics of that should be. And when Tokyo was first released, it was incredibly complicated, and a lot of people really struggled with it. And one of the big things we've been tarrying with is the event loop and whether or not we should make it explicit or implicit. Like, I know my first experience working with Tokyo was I wrote all my code perfectly, it compiled, but nothing happened. Does anyone want to guess what I didn't do? Start an event loop. So it just didn't go. And so I think we still don't really know exactly what we want the ergonomics of it to look like, and therefore we're still working on it. There's a,
It did not.
Can you scroll down so you can see the code sample?
Oh yeah, there's a little bit. This is the this is non-AsyncAwait with all the manual stuff, but it's basically like she forgot this line, so like Tokyo run. So
If you, I was gonna say, if you pulled up my talk from the conference, you could show the AsyncAwait code.
maybe you can do that when you're up here in a minute. You'll have it ready, and I don't have it ready. Yeah, it's cool. But yeah, so there's a lot of questions in general. I guess the full answer.
I think you mentioned like a working group or something in your last sentence and didn't.
Yeah, sorry. So part of the thing that we're releasing with the edition is Rust is primarily focused on either very advanced users or very beginner users. And that serves us very well because the vast majority of people who come to Rust are, brand new to Rust. And we have actually been around quite a long time, but not in a sufficient way to like build up a solid number of intermediate developers until around now. And so in order to try and fill the gap of language features and as well as documentation, we founded these 4 domain working groups. Because one question that you get a lot, and I assume folks who are showing up to the very first Rust Barcelona meetup probably have this feeling too, which is you go, hey, you should use Rust. And people are like, I've heard of Rust, I hear it's cool. What the heck do you use it for? And it's like, that's a reasonable question people really struggle to answer. And so we picked 4 things that we think Rust should be good at. And those working groups are working right now to make the developer experience of building those things work. And so that means building external libraries or championing and design features in the language. And so yeah, that's kind of what those are. And so one of the working groups, the network services working group, is focused specifically on HTTP library, all of this stuff, all of the AsyncAwait stuff. Part of the reason they're like a little bit behind the rest of the groups, you can see their name is not linked. That's a lack there, and it's because AsyncAwait 0.2.1, I think. I don't know.
It took a long time to get AsyncAwait
Oh no, it
design
was
to work.
Future
0.2.
Yeah, they made a controversial decision to release Future 0.2 that held them all up a whole bunch. So they started like 4 months after everybody else started.
Yeah, but so hopefully by the end of the year, like Rust will be pretty good at network stuff, command line apps, WebAssembly, which is what Ashley's gonna be talking about in the group she's most involved in, and embedded devices. So we have like dedicated teams working on these 4 things. And so when you're like, what can I do with Rust? These are kind of going to be 4 things that we hope by the end of the year are not only going to be like good to use Rust for, but have like great documentation. So there's literally going to be like a mini book on each one of these topics that explain like how you can get into it for exactly that, like intermediate sort of reason.
Yeah, the like prerequisites would be like you read the Rust book. How many people here have read the Rust book, by the way? Yeah, the one online. It's the same as the one that's printed. The idea is like, it's kind of tricky right now to be like, oh, I just read the Rust book. What do I read next? There's not really great support for that. And so we're hoping that each one of these teams is going to produce something that's going to be kind of an awesome next step. Choose your own adventure style.
Yeah, and like they have projects and like all that kind of things all sort of coming together. I hope that answers your question. That was like a lot of stuff. Cool. Yes.
I could ask a related question.
All right.
Yeah, so you mentioned Tokyo, and we saw something about creating a socket to listening a TCP connection, right? But how about if you just want to serve HTTP requests?
Yeah.
I took a look at Rocket earlier, and it's cool.
I was gonna bring
but
up
I wanted
Rocket
to ask, so just to phrase the question, so there's Rocket, And what else? What is the stale part?
Okay, so for those of you who haven't seen Rocket, Rocket lets you write websites by basically doing this little attribute for the URL and the function name, and you print stuff out. So this is like a web server, so it's much higher level. The one that's like the new cool kid on the block is Actix, and it sort of looks very similar in some ways. The difference is that Rocket relies on a lot of nightly only features, and Actix works on stable.
Macros.
Yeah, procedural macros is like the big one, and those are coming to stable soonish. But not all the stuff Rocket needs. It's like it's a little up in the air exactly. Actix is a little slightly harder to use. You can see there's all this stuff here, but it works on stable Rust, so your code won't break. The cool thing about Actix is that the guy who works on it a lot during work hours, and he works at Microsoft. And when people asked him, like, does Microsoft, he works on the Azure team, and people were like, is Microsoft using He was like, there was a thread where he was answering all sorts of questions about the new release of Actix, and someone was like, hey, so is Microsoft using Actix inside of Azure? And then he immediately stopped answering questions and didn't say anything else. So I can't tell you that they are using it, but it implies pretty heavily that he's actually using it.
It's getting reported.
It's actually true. It's like soon he's gonna like be a thing. So it's
We're professionals.
Totally, we're real professionals. So that's kind of like a cool thing people are really excited about. There also was some drama recently around Actix that got resolved because this first thing here is like type safe, but it turns out that like they use the unsafe feature to get around the type system like a couple of 100 times inside the code base. And so people got very upset because they felt betrayed. And then the guy was like, okay, let's work together to fix it. And a bunch of people came together and they removed almost all of them. So that's been like sort of fixed now, but there was also a little sort of kerfluffle about this. The other one is that there's going to be a new web framework by the Tokyo people that's going to come out like soon. And it's like called Tower, and that's all I know about it. So I actually did it's like Sean Monstar is like doing a framework. I actually, earlier today, I did a list of like web frameworks in Rust, and one of them was like still maintained or not. Yeah, I know, but I personally put one together, and it was like there was like 15 entries on this list, and like half of them were abandoned, and half of them were still being worked on. So there's a lot of different options, and many of them sort of are like, I'm Sinatra, but in Rust. I'm Flask, but in Rust. I'm Express, but in Rust.
How many there are.
Yeah, like there's a whole screen of just web frameworks. And so there's a lot of options, and we're trying to. That's not necessarily a good thing, right? Like I come from Ruby world, where it's like you probably use Rails, and maybe you don't, but you probably do.
Or you reinvented Rails in Sinatra.
Yeah, or you wrote your own Rails in Sinatra. And so definitely one of the problem areas with the web services is that there's no good sort of default choice right now. There's a lot of options, which is neat, but also it's sort of hard to decide like which one of these 15 libraries should I use.
Same with the graphics engines.
Yeah.
You have a bunch of options.
Totally. It's like nice to have a lot of options, but it's also terrible.
Yeah.
It just depends on what day that I woke up in. So yeah, hopefully that sort of answers a little bit.
So you showed that recently you implemented the Infiltrate.
Yeah.
So what's the difference between that and bounded generic with traits?
How much type theory do you know? No, it's fine.
Not much.
This is part of the problem is that it's, so basically, I'll actually write some code real fast to explain the difference. Okay, so the question is basically like I have a function foo.
Probably say what that is.
I'm going to type it first and then talk afterwards because I'm going to mistype like a lot. Okay, so this is sort of the question between these two forms, right? Like, what's the difference between these two things? So, again, we sort of didn't talk about traits the whole time, but if bar is a trait here, there's sort of two ways to write this kind of same concept, and one is this function foo is generic over any type t that takes in the bar trait and it returns the t, and this one says foo returns some sort of thing that implements the bar trait. And that's like the same words just rearranged in the sentence. The difference here is if you think about the difference between parameters to a function and return values to a function. So in a parameter, the person calling you chooses what to pass in, right? And then in the return value, you as the programmer choose what to return. So that's like the difference between going in and going out. It's like chosen by who calls you and chosen by you. And so in this form, this is an argument to the function. And so this says the person who calls foo is going to tell me what that type is, and then I have to return something of that type. And that's like almost impossible to do. And so this is like not super useful for that reason. It is every once in a while, but like very rarely. And this is the opposite. So this says that I'm going to give you something, and I as the body of the function get to pick, and I'm not going to tell you what it is, but it's going to be some kind of thing. And so that has like sort of slightly sort of deeper implications. But roughly that's kind of like the difference between the two is this is like passing in an argument and this is like returning a value when it comes to the types. And so this is extremely useful and this is almost never useful is like the simplest answer I can basically give you.
So is the function below result of compile type too, or is it dynamic?
Yes. The compiler knows what the type is, but you as the programmer don't get to know. And that also implies that you can only return one possible thing. Like you can't say if this returns something or that returns something else, it'll complain because it's like it needs to be one specific thing. And to do that, you have to go back to the box situation with the dying trait is the difference. If you want to turn multiple things, like this says, I'm going to return only one kind of thing ever, but I'm not going to tell you literally what the type is. And the return dyn bar would be like, I'm going to return multiple kinds of dynamic. Anything else?
Well, it's a little off topic, but in theory, like one of the reasons why Rust was created is because like Mozilla wanted to change like the engine from C++ to Rust. And how's like the state of that? Because like as Rust is like improving and changing all the time.
Totally.
Like,
so,
is it like something to?
Yeah. So he opened Chrome on this computer, not Firefox, so I can't do my showy. You've been using Rust this whole time because in Firefox now, all of the CSS is handled by Rust code. So like every web page you open in Firefox now has Rust in it, and so that's one of the sort of bigger areas. They're actually they're doing an experiment next week where, so if you use the nightly version of Firefox, you kind of opt in for Mozilla to experiment with you. And so next week, if you use nightly Firefox on Windows 10 with an NVIDIA graphics driver, 50% of the people are getting a graphics stack that is entirely in Rust, and the other half are not. And we're going to see, hopefully that half does just as good as the regular old half. And so that's the next big section that's called web render, and that's like all of the graphics drawing on the screen is in Rust. And it works. I actually have it turned on always personally because I know the people that make it, so if it breaks I can like tell them. But that's going to be coming out pretty soon, and that's sort of the next big step. But we're kind of taking it bit by bit, the sort of little chunks that are happening, and those are the two big projects where first the whole CSS system, and then now graphics. I'm not sure what the next big thing is going to be after the graphics, because that's taken like, each of those things took like 2 years overlapping, like, 2 years and then 1 year where it was both, and then now it's this next one. So I don't know if they picked what the next sort of big thing is, but that's the biggest thing inside of Firefox, yeah.
And if I may ask, like, why they decided to change it? Because like in theory, like when it comes to performance, C++ is like the best.
Yeah, so the thing is that we actually can be faster than C++ sometimes, which is interesting. But that also,
Sorry.
But that also was not why. It's off topic in the first place, so he said it. So we can be faster than C++, but that's not actually what's important. The thing is so for example, that CSS system, we tried to build it, so it uses threads, it's like the big thing, it's multi-threaded. We tried to build it in C++ twice and failed both times because threads are so hard. But Rust helps you with multi-threaded code, and so we were able to do it in the first place at all because of Rust. And so that was the real reason that it was chosen, just because we got sick of trying it in C++ and not working. So that's like the bigger actual reason. Yeah, and it's thanks to all the like super strong type checking stuff. Like we're able to type check your concurrency things. That's really, really helpful. That's sort of that. Yeah, that's the big reason. All right, I saw one more hand, and then I probably should get off the stage. I talk to you all the time, so I'm gonna pick someone else over you this week. Anybody else? Yeah.
I saw the changes in lifetimes are coming.
Yeah.
That's one thing that forward checker is about.
Yes.
On my code all the time.
What are the changes?
So, quick overview of that stuff is a lot of annotations are going to get inferred instead of you needing to write them out yourself. But there's a big feature called you may have heard of called non-lexical lifetimes. It's been worked on for like 3 years or something. Not the version of Rust that's coming out next week, but the version of Rust that's coming out after that is going to be the first. We hope it's the first one that's going to be turned on by default. But that's sort of the plan, and that's the real biggest change. And the shortened version of what that feature is, if you haven't heard of it, is there are some situations in which the current type checker is really stupid. And so you have a thing that's actually okay, and it's like, that's not okay. And you're like, oh, but I know it's okay. And it took us a couple of years, but we taught it that those situations are actually okay. So there's going to be like it's not really a feature in terms of syntax and stuff, but anytime that you check something with types, you want to be conservative instead of liberal. So you want to make sure that you're always right rather than sometimes a little wrong. And so we were a little overly conservative in the sort of first version. And so we're going to be a little less so. And so more stuff is kind of just going to work. You'll get yelled at a little bit less in many situations. So that's the big one that's like literally years people have been like, when is this happening? And we're like, hopefully soon. But like that's actually the plan is 128, 129 is coming out next time. 7 weeks from now is like when it's going to actually happen. Assuming it doesn't totally break when we do the beta, basically.
Will be next beta.
Yeah. Cool. Well, thanks so much, and I'm happy to talk more afterwards, but yeah, I don't want to take up too much time, so thank you.